Now, the key question, of course, is how long was the hallway? Group
34.3.
Yeah.
34 meters.
How did you, okay, so we're gonna unpack that right away as well. How did you get that estimate?
We knew how tall we were, so we kind of knew what our wingspan was. So we used our wingspans to measure the hall.
Okay, so you used your body length essentially via your arms, and you sort of like looped yourself to measure it.
Yeah.
Cool. Okay, and so that was your. So I guess a question for you that maybe is the most important question is how many wingspans was the hallway?
Well, we used 3 people, so I guess it's kind of variable. But say if we were to use, I don't know, it was like
It's like almost 20.
it was 6 of the 3 of us. Yeah, probably around 20.
Cool. So right away, let's pin that in our mind because it'll be related to a question I'm gonna ask both of you as well. Is that there's 2 numbers that you had. One was it 40 something and what was it?
34.
34 meters,
Yeah.
and the other was 20
Wingspans.
20 wingspans. Okay, so those are both estimates of how long the hallway is. Okay, that's very, very good. So you had a different hallway. How'd you measure your hallway?
Well,
Similarly,
yeah, we're both 5'3", so we determined if our wingspans were the same height as us, and then we measured it that way.
Okay. So you also used wingspans?
Yeah.
Okay, cool. And you, in that point, also had a wingspan number and a meters number, correct? Okay, cool. What other strategies did you think on when you were trying to figure out how to measure the hallway? I saw lots of pointing and gesticulating. So what other methods did you think about for how to measure before you settled on wingspans?
Using feet.
Like literally feet?
Literally feet.
Yep.
That would work. Paces.
Paces, yeah.
really obscure way of knowing your running speed. If you're a sprinter and then running through it and timing it.
Did I see someone pointing at the ceiling tiles or trying to use like visual indicators like or ticks from the environment? And why'd you rule that one out?
Couldn't measure couldn't get a good idea of how wide these are because of too far away to be precise.
Okay, and now, so, and one of the, I just wanted to bring up the thing that I said I'd bring up is that also you asked me, what did you ask me?
If I could use a piece of paper to measure,
Cool.
to compare it to the size of my foot,
And why did you want to do that?
because I know the dimensions of a normal piece of paper,
Cool, and why were the dimensions of the piece of paper important?
because then I could get an accurate measurement.
Cool, and then what were you all assuming I was asking when I asked you how long the hallway was? What were you assuming about what I really wanted?
The length of the hallway?
The distance from like the beginning to the end of the hallway.
Yeah, you were assuming something though. I think what you were all assuming is that I wanted an answer in meters and feet and inches. And now that's really, the reason this is really interesting is that from your, let's imagine that there's 2 perspectives one could take on the problem I posed to you, and I think you all took the very natural perspective, and that there's a subjective and an objective way of thinking about that problem. One is that I actually require, there's like a ground truth value, which is how long the hallway is in some agreed upon units that we've all established. The subjective view is that the only way to measure, or the most natural way to measure the length of the hallway is in terms of something that's directly observable. So I wasn't letting you use tools or like use the piece of paper as well. Is that, I mean, those are both very, very legitimate, reasonable ways to measure the length of the hallway. Turns out our measurement units are something we've come to through an alignment of those subjective views. But when I asked that question, I would have been very happy if you came back and said, yeah, it's like 308 footsteps. That would have been okay too. And the reason why this is okay is because really from the perspective of our learning machines, a lot of our machine learning algorithms, our machine intelligence algorithms, the only thing that they have to access is their raw data stream. So when they're trying to estimate quantities or estimate like those values that I was talking about earlier to make decisions, they're using their raw data stream. In some cases we require that that is aligned, or we engineer that that's aligned with other more objective measures. But really that subjective viewpoint is something that's often underappreciated when people think on machine intelligence. And so that's why I was hoping that this exercise would be helpful, is to think about, well, what were you were assuming that I wanted some kind of objective frame, but that there's also this subjective way of viewing quantities, distances. Like, so ceiling tiles in that case would have been totally reasonable. You're like, oh yeah, I passed 58 ceiling tiles. I used my visual apparatus to see 58 ceiling tiles. That's something you can do if you repeated it. So let's imagine you repeated that, the ceiling tile walk. for the length of the hallway, how many times would you have to repeat it to get a perfect estimate?
Infinite?
For the ceiling times?
I don't know. Well, I guess you mean how many? I don't know. Probably a couple of times just to make sure my first one wasn't errors.
Cool, right? Like maybe there's noise, maybe there's noise in your sensory motor apparatus. Your visual stream is not, or your processing stream is not reporting accurately, so you want to run it a couple times. Likewise, if you were using strides, there might be variation in your strides. You'd want to run this experiment several times to figure out the exact number of strides it would take. The other question I posed to the two of you was, okay, you were done. You're like, yeah, we got our short hallway, so we did our arm lengths really quick. I was like, okay, how many? The new quantity I was asking you to estimate was how many people will pass you or will you pass during your traversal of the hallway. So now, what was the first thing you said? You said something. I think it was, you said something right away after I asked you to do that.
I just said 3 because there was 3 people at the end of the hallway.
And before that, you're like, well, what time of day is it? Those are two things that came up very quickly, and it's very, very important because, like, if you were to run that experiment, now let's take the very subjective view. You have essentially a counter. It's a counter you can perceive when someone crosses your path. That's the only thing that you have. That's the only sensor you really have as you traverse the hallway. You went down the hallway once and you got 5, I think, and then you went down again and you got 4, and then everything was all set because it was an empty hallway and it was just us, and then some other person looped into the hallway, but I didn't walk down the hallway, and you got 4, but it could have easily been 5. And so you were also then building up estimates, and the answer for how many times would you have to run that to actually get a good estimate, I think we agreed, what, infinity? It was a lot, right? And you said it depends on the time of day, like you were both commenting on how this is like, this actually really depends on what we know about the timing and the scheduling. That's other sensory information you might need to make good estimates. If I could say, well, let's do this twice. Let's do that experiment, to count the people that pass you on the weekend and on a weekday. And you spent all day, during a weekday walking back and forth in the hallway and counting a number, and then you make some average, and you did that on the weekend. And now you have sort of 2 bins. You're like, hey, yeah, when the state is weekend, here's my answer. And when the state is weekday, here's my other answer. You're essentially, that's like location 1 and location 2. You're building up those estimates through experience. You're running this many, many times, and every time you're incrementally changing your estimate about how many people you're going to pass. It might be that because we're in the middle of a class block, that of course there's not going to be any people, but if we were to ask about the temporal period, which is the whole day, there's going to be those bursts between classes where you're going to pass a lot of people as you're walking back and forth. And to some degree, it depends on your actions as well. It depends on the fact that you were like, I'm staring at you while I'm saying this because you were the one doing the walking, but that the actions that are taken matter. The traversal is governed by the length of your stride when you choose to walk. Sometimes when I do this exercise, I actually have people have a coin or a multi-sided dice, and I say, okay, you're going to do this, but you're going to stride down the hallway, and every time you step, you're going to roll, and on a 1, 2, or 3 on a 10-sided die, you're going to walk backwards, and on the rest, you're going to walk forwards. It's a stochastic process. And now, the estimate of how many people you pass or how many doors you're going to pass, even let's imagine, take people out of it, how many doors will you pass? Depends on the probabilities that you roll on that dice. And so you have to run this experiment. Let's assume there's no other people we care about, it's just doors. You have to run that so many times to get a good expectation. This is the problem that our learning machines face, is that there are probabilistic elements to the world. There's uncertainties and non-stationarities and non-observabilities in the world. So as learning machines, especially reinforcement learning machines, learn to build up valuations of the actions and the states that they're in, that they have to sample experience many times to be able to build up those good estimates, to take into account all that variation. It's really like being a good scientist and running really good experiments. These systems, these learning machines are in fact like scientists. They're running experiments, they're running tests, and trying to build up values and estimates that are going to say what actions they should take or what states they should or should not desire to be in. If the signal you were estimating was reward, then you're seeing how your states and your actions impact the reward you're going to get, assuming you're in states and taking certain actions. Is that cool? Is that like a good way to ground it? So when you're thinking about how reinforcement learning learns through trial and error, think of yourself like trying to interact, moving through the hallway, and trying to actually using your subjective stream experience, estimate certain quantities or values during your flow of interactions in the world. Okay, is that cool? Like, any questions? Any other feedback or thoughts on that? Yeah.
Well, I guess like if say machines are learning and they have all this experience in the background to I guess create some concept on how they're going to succeed. Is it better to, I guess, reinforcement learning for a new machine, like a fresh machine without any bias, or is it better to retrain, I guess, the one that's already has some bias on it? Is that going to be like a problem?
In this whole setting, actually, in a broader sense, that whole the problems less question is phrased can be thought of as like, do we actually use, like, can prior information actually be reused? Do you need to start from tabula rasa? How many samples or how many samples of experience, how many interactions are required to learn a target concept? In some cases, it might be vast, in which case you might assume that, well, it's really important to try to change a system that's already learned as opposed to learn something from scratch. One of the examples that we sometimes see is in a lot of the computing science literature, and especially reinforcement literature right now, you might have machine learning agents which are running around in games like Atari or in three-dimensional games, and they're trying to learn how to process the visual scene, how to take actions in that scene. A lot of learning is spent just learning how to find edges and lines, like the visual cortex part of it, building the right weights for what's called the convolutional layers of the neural network. That's a huge amount of effort, it's a huge amount of samples. You could argue that probably you could just take any agent that's been trained and you don't need to retrain that entire first part of the network, the part that understands or processes visual scenes and turns it into elements that can be used for decision making. Maybe you only want to just throw it into a new situation, have that downstream decision-making change, as opposed to relearning everything about the visual scene. So there are many situations I think we would want to reuse things, but there's certain things that once you've learned, systems that get trained, like my dog is a great example of a system that once learned, like he used to chew his bone in the family room, and now he chews his bone in another room of the house. When we give him his bone, he still runs to the other room and then runs back. Even though he knows I'm pretty sure he knows that eventually he's going to end up in like the room with the fireplace. But no, he always goes back to the other room and then loops back, even though it's been like 2.5 years since he was actually allowed to chew his bone in this other room. So sometimes there's behaviors that are entrenched in a learning machine that are very, very hard to unlearn because you have to get to a situation that's identical to one before, and then at that point have stimulus that forces you to unlearn that particular behavior. So that's why that's a really detailed question that you were framing, and it's actually really important, is that in certain cases it's very, very hard to modify behaviors, especially in very complex domains. If it was like a little chessboard and you're trying to say what decision do you make in a cell of the chessboard, maybe it's easier, but in a wild, squishy world like we expect our system to be deployed in, then that's a very relevant question, whether or not you actually have a learning machine, you train it from scratch, and you do so because like you bite the bullet of having to use a lot of experience for the system to learn, but then you know that it's going to be well performing in that domain, or whether you try to adapt something from another domain and then also have to then worry, well, what things have been learned that are very hard to unlearn. This is true for humans as well, I think. Habits. When we habituate, when we like, oh yeah, every time I get up, I'm gonna like check my email. Like, even if I don't want to, I'll probably start to reach for the phone. It's really hard to unlearn habits. Someone once described it to me anyway as like, as you're on top of a nice snowy hill and there's only just powder snow everywhere, and then you get in your sled or you get on your skis and you go down the hill. Cool, you made a trench. Next time you go down, you're going to be pulled back into that trench, and the trench is going to get deeper. And every time you go down, you're going to go down that same trench. My dog runs into the room before he runs into the other room. So actually breaking habits or breaking those ingrained policies requires almost jumping out of the track and then making another track, and then doing that enough times that you sort of beat down the wall of the first track so you can move into the second way of behaving. This is really intimately connected to the idea of models. So if you're simply a trial and error learner like the ones we were just doing in the hallway where you're walking and building estimates, it's actually going to take a lot of experience to unlearn one thing and relearn the other thing. If, however, you had a model of the world, if you had some kind of mental construct which said how one thing connects to another thing, then it's very possible that you might be able to, in fact, change your behavior more quickly without having to do as many samples of real experience. You might be able to imagine the way that the world unfolds, and then say, well, okay, if I did go over there, I know that this connects to that and this connects to that. Location 1, location 2, I know how those connections are formed. That maybe you can start to propagate the values from different ways of behaving back to your current situation without actually having to do that and do that long path of experience. So people appeal to models, and there's many things that people mean when they mean models, to allow a system to learn more effectively, more efficiently, or change its behavior, even in the absence of more experience from its real interactions with the data stream or with the world. So that's why people might care about models. And you hear about model-based reinforcement learning, There's also neuroscience, reinforcement learning of model-based and model-free reinforcement learning of biological organisms. Some awesome folks doing work in that neuroscience community, looking at how animals do both model-based and model-free learning. Cool, that was exercise 1, and we are currently still in really good shape for exercise 2. So I think we're just going to do exercise 2 and not exercise 3 for right now. Do I want to do, maybe we do want to do, no, you know what, let's do exercise 2. We're gonna skip exercise 2. This is an exercise called dolphin training, and thanks to my my ex-graduate student Corey Matthewson, who really introduced this as an exercise. And it's going to be control learning. So control learning is we just learned about estimating values, and now what we're going to learn, we're going to explore how machines will begin to learn how to behave. Okay, based on signals of good. Exactly what we were talking about at the very beginning. And so what I'm going to need, in fact, there's 5 of you. But I'm going to ask for 4 volunteers. So one of you's off the hook. Who wants to be off the hook? Nobody. This is rare. Okay. We can switch things up then, and can we do it with? Huh. You know what? I'm just going to ask for one group of 2. That'll make it more fair. That way, one person isn't left out. One group of 2 who wants to stand up and do a silly exercise.
I'll volunteer to sit out. So I
Okay, I volunteer to sit out. Okay, usually it's people like that. I appreciate you all want to be active and engaged. That's awesome.
Yeah.
Okay, so you volunteer to sit out. I guess we can do 2 groups then. So can I ask you 4 then? Thank you for being the sacrificial sit out person. You can help me judge. You can help me judge those that are acting. I figure out your teams of 2. You're going to divide yourself into teams of 2. Okay, so I think we've already seen that sorting process. And then stand up here at the front in your teams of 2. And I'm going to head to the back. We're going to hang out back here. Okay. So, this is an exercise called dolphin training, and it's called that for a reason. Is that one of you in each pair is going to be the dolphin, and one of you is going to be the dolphin trainer. Okay? So, sort right now, before I tell you what that actually means, who's the dolphin and who's the dolphin trainer? You'll switch, don't worry. Okay, who's the dolphin trainer? Raise your hand, dolphin trainers. Okay, dolphins. Hopefully that was clear. Okay, awesome. Now, what you are trying to do, dolphin trainers, what you're going to do is try to get your dolphin to do something. Okay, it could be an activity, it could be like moving objects in the room, it could be moving to a location in the room, it could be doing a handspring and then getting you a coffee, whatever it is, the dolphin trainer is trying to get the dolphin to do something. Now, dolphin, your job is to figure out what is that your dolphin trainer wants you to do. Dolphin trainers, tricky thing is that you can only, and the only things you can do are look at your dolphin and with no facial expression go, or whatever that means to you, you have 2 signals you can give. You can't point, you can't wink, you can't nudge, you can't be like, you could just go, or, so trying to keep a straight face is really hard. I acknowledge this, but when you're done, so dolphin trainers, your only signal you can provide is a signal, like, again, those 2 signals, let's call those signals are good or bad, but you don't have to assign which one you think is good and which one you think is bad. So you have 2 signals you can give to your dolphin, and that's it. You can't tell them anything else, you can't work with them beforehand. And the dolphin, you have to try to figure out just from those signals what it is that your dolphin trainer wants you to do. Okay? Does everyone understand? Is that pretty clear? So, dolphin trainers, when your dolphin does the thing you want to do, go, yay! And then you are done. And arguably you win if you get your dolphin to do the thing before the other team does, but that's not really the point. The point is to get your dolphin to do the thing. We're not really making a competition here. Okay? All of us here will sit and watch and make sure you aren't doing all sorts of other funny, like, pulling on your ear and things to signal to your dolphin. Dolphin trainers, you have 30 seconds to figure out what it is you want your dolphin to do, and then we're going to start. Okay, you're good? Okay, then on your mark, get set, dolphin training. Okay. Yay! Okay. So that was okay. So back up to the front. Okay, that's awesome. So the objective dolphin trainers, your objectives clearly were get your dolphin to both sit in chairs, just different chairs. That's given our sort of impoverished environment here. This is a very reasonable thing to do. Okay, switch. So now dolphins, you're dolphin trainers. Dolphin trainers, you're the dolphins. Okay? And now you got 30 seconds for the new dolphin trainer to come up with something, and try to make something a little bit harder than the last one, or something that's a little more complicated for this next one. Okay, so about 30 seconds. Oh, you're good? Okay, then go ahead. Train your dolphin. Okay, wow. That was fast.
Oh, are we still going?
Yeah, keep going, keep going.
Don't look at me so you know how I feel. Yay. Oh.
Yay! Okay, awesome. That was okay so far. So now, I think we should all between the four of you, I'd like you to sort of come to consensus. Which one of you is like, which one of you feels like the most skilled dolphin trainer of the bunch? Which one of you thinks like you're the best of the dolphin trainers?
No.
Well, I get ask me one of you two then.
I think we had it easier because we had more to choose from on this side
Okay.
versus just chairs.
Well, okay, you then flip a coin. Which one of you thinks you're the better dolphin trainer, or just I don't know, argue among yourselves.
You're a good trainer.
Okay,
Take it. Sure.
All right, then the best dolphin trainer. You're all still up there. You are now dolphin training 3 dolphins at once. That's why I was like, you totally lucked out. So you're all now the dolphins. Alright, so you're all the dolphins. You have to train all 3 dolphins. So think of something that you need you need to have an idea in your mind what all 3 dolphins have to do. Some configuration or some success criteria involving all 3 dolphins, and you have to train them all in parallel.
Is it supposed to be like collective or like?
It's completely up to you. I've seen things like I'm going to say just for safety reasons, like not human pyramids, but I've literally seen human pyramids be one of them, or like some kind of like interpretive dance routines have popped out of this before, so it doesn't have to be that complex, just given the time we have left for the class. But so think of something that you want your 3 dolphins to do, and then try to work with them. I'll give you 30 seconds to figure that out, and then you can get to start training. You got it?
Yeah.
Oh, you got it already. Okay, in that case, 3, 2, 1, dolphin train.
You have to move.
Yes, yes, fix the classroom. Fix the classroom, excellent.
I'm not going to help with that.
This works.
There. Next one. Stop. Oh. No. No.
How did it be on?
It's fine. Yay! Oh, you're just on. You just keep it back on.
Oh, this is not stable. Tom's still not on.
Okay, I think just take it off the roll for now, and we can place it somewhere safe, given that I'm still where he was in. Okay, so that was what you wanted? Okay, awesome. Let's all clap a lot because thank you for being engaged and brave and active in this one. So let's talk a little bit about that in the time we have left, and then I'll sort of wrap things up. That was awesome. Thank you all. I've never seen everybody try to do some kind of like infrastructure or like facilities project together. That was a new one. That was really cool. I've seen this run. We ran this at Corey actually ran this at one of the Barbados reinforcement workshops, and we had, it was like 25 researchers all running around out the back of the Blair's Research Institute McGill, like doing this particular dolphin training exercise. It was fun, and then one person had to train the entire batch of like 19 other researchers. It was fantastic. Senior research scientists are like, hanging from trees and things. It was fantastic. Okay, cool. So first off, just from the perspective of you were all dolphin trainers at one point. So let's think about the single person dolphin interaction. What was tricky about being a dolphin trainer?
Couldn't talk.
Yeah, right? Your bandwidth was so limited. You get like one signal, really. It's like good or bad, which I assume you all agreed that this was good and that was bad? Yeah, so social convention, we had that built in, but you could have easily flipped it where this is good and this is bad.
Horrible.
Yeah. Yeah, so certain cultures this would be like a yes signal. I can't do it right, but that this is actually yes. So I mean, it really is like we already had preloaded semantics, but you got two things. So that was tricky. What else was really tricky about being a dolphin trainer?
You weren't able to provide any kind of redirection. It was just yes or no.
Yeah.
And so like coming up with possibilities was all on the dolphin.
Right? So there's like the behavior that we'll talk to the dolphins later as well, and from the dolphin perspective, but that it almost required some kind of random action on the part of the dolphin, right? Like if the dolphin just stood there and did nothing, then clearly your no sign might have mean many things. Like, so if your dolphin was just sitting there doing nothing, and you go like this, what do you mean by that? Like, what were you, as a dolphin trainer, what would that mean to you? Just that if your dolphin's not doing anything, you're shaking your head. What were you trying to communicate to your dolphin? Move, right? So, in some way you're saying what you're doing is bad, but you're also trying to do a lot with that signal of reward. You're also trying to say, in fact, not just what you're doing isn't okay. It might be okay later, but right now I want you to do something different. There's like, you're trying to communicate a lot through a very thin channel, that single signal of good or bad. In this case, it's not even like a number that goes up or down. Remember, like when I asked you to define RL earlier, tell about RL, we're saying, yeah, like it's you're just giving a number to approve or disprove. So dolphins, what was tricky about being a dolphin? I mean, you're all dolphins, so you can all answer. But
Uncertainty of like not knowing if what you're doing makes sense at all to what you actually have to do.
yeah, how did you choose what to do as a dolphin?
Random,
And then what did you have to wait for?
a positive signal
Yeah. And when you got that signal, what did that signal mean to you?
means you're on the right track.
Okay, cool. So like, there's many things it could mean, right? It could mean like what you just did was good. What I think you're about to do is good. That's also tricky because it might be that you see someone reaching for the chair. It's in fact not the reaching that's going to be good. It's that the future outcome of grabbing the chair and then lifting it is what's good. And so you're we call these shaping rewards. In fact, there's a whole field that's looking at how you provide intermittent rewards throughout a learning process to get the system towards the big reward at the end. And so you're all providing what we consider to be shaping rewards, and dolphins, you're trying to figure that out. The other thing that I always notice when I see this exercise run is that the trainers and the dolphins have to keep visual contact. Like they actually, the dolphin isn't always able to observe, depending on what they're doing. If they're actually doing a handspring or something like this, they can't be observing the reward signal, that feedback signal from the trainer at all times. They in fact are having to modulate their attention between what they're doing and then getting feedback. And the dolphin trainer might be like, dolphin, why aren't you looking at me? I'm giving you feedback. This didn't happen today, but there's times where I've seen like the dolphin trainer's like going wild and the dolphin's like, off in the corner, climbing the walls. And you're like, no, dolphin, what are you doing? So it's really interesting though, because it does require, this is a really interesting learning environment where the system, the dolphin, in this case, has to be, in fact, observing many things about the world and has to choose what it attends to. And some of those things might relate to its performance in the task. This is a really fundamental reinforcement problem, which I like it. For the dolphin trainer of 3 dolphins, what changed? What was different when you were dealing with 3 dolphins instead of 1?
Well, I guess thankfully, the task I chose was the same for all of them. So at least the general positive or negative reinforcements could be generalized to all of them, as opposed to if I chose to make them do 3 separate things. But establishing visual contact was obviously a lot more difficult.
You had to gate between, imagine if they all were doing different things, or you need them doing different things, you'd have to almost be like moving between the different dolphins. That was really clever on your part to choose something where you could give a sort of a broadcast reward signal if everyone was doing the right thing as opposed to not, and then hope that they sculpt together on it. But yeah. Any other observations about that?
I guess they'd have to like come to the conclusion that they were operating as a singular unit in the first place.
Yeah.
So to decide what to do would have been infinitely more difficult.
These multi-agent situations are really hard. So this is also like when you start thinking about multiple learning agents, they're all learning and trying to learn to coordinate their activities. There's a lot of work being done now in games and in game theory that's looking at how learning machines can start to coordinate their activity. Another professor on campus, Michael Bowling, and his team have a really awesome paper a challenge paper on Hanabi. If you haven't played Hanabi, it's a great game. It's a card game where you see all the cards on the table except your own, and you have to work together as a team to play a series of colored cards from 1 to 5 in the middle of the table without playing the wrong card, even though you can't see your own cards. Wonderful collaborative game, and it's an interesting challenge where we have multiple agents. They're trying to learn how to interact and pass information so as to be able to complete a task together. So there's a lot of really cool work being done now on machine learning. I just play Hanabi just for fun. It's really worth doing. But it's a really challenging domain. So I hope those two activities, so I just wanted to sort of summarize the two activities and I'll close out for the day because I think we have like 8 minutes left. 6 minutes left. Okay, is that one was looking at estimating value. And the other was that assuming that you sort of had a direct line to reward, how do you actually change your behavior with respect to that valuation and that reward? So we looked at value learning and policy learning. Those were the two things that we just looked at. And that's a really nice microcosm of the full range of things that we expected in the reinforcement learning, the full reinforcement learning problem domain. So those are hopefully hands-on activities. And thanks for being really active and actually participating in those. That was really good. So I'm just going to close out with a broader view on machine learning, machine intelligence. And one of the things I think is really important is that machine intelligence in particular is looking at how the machines can make good decisions in unknown, uncertain, or changing environments. We talked about why learning was important earlier. My view is that it involves algorithms and applications. So like there's clearly some kind of machinery that is in play here, algorithms or different learning machines. There's some goal that's trying to be affected. And there's architectures in the middle that try to help the system make those decisions, that bring the two together. So another way to think of it is in the very far edge, farther on the left is data, and the very far right is goals, and decisions are the thing that fall in the middle. And what goes through this, and the things that we studied a little bit today, one is representation. How a learning machine or how an intelligent system will actually structure the information in the world around it. This is one of the fundamental things. When you mentioned unsupervised learning at the very beginning, a lot of what people in the field of unsupervised learning, or learning from the raw structure of the data, a lot of what they study is in fact representation. How a system can start to take all of the facts and features of the world and turn it into some kind of crisp representation it can use to make decisions. The next bit we looked at was that estimation or that value process. Really, this is a process of prediction. It's a process of predicting the value in a situation given your experience. And then finally bringing all that together into what we call control or policies. How do you use that, your way of structuring information in the world and your knowledge or the information you've built up about the world and how the world operates to make good decisions, to control your own behavior so as to be able to operate in that world and maximize that single signal that we all talked about being important, signal of scalar long-term reward. So that's the, and these are, I would like to say that all three of these things are knowledge, and they leverage this process of continual learning in a true reinforcement learning system that we expect to continue operating in a domain, not just a small episode, that really a system would hopefully be changing its representation, updating its knowledge or predictions, and changing the way it behaves, its control behavior, its control of its own processes, in response to data from the world, and in a long-term and ongoing way. And that really is, especially for the full reinforcement learning problem, how you can imagine an agent starts to be able to choose how to take good actions in a world when it's just interacting with that flow of observations from the world and that single signal of goodness or badness that we call reward in that experience. And that's it. That's it. Thanks so much, folks. Do you have any questions? Like, we've got 3 minutes left for questions. Any questions on what we worked on today?
So what they may not know is that you and your mother are both on the faculty, right?
Mom is now retired. I think officially retired.
Cool.
But yeah, she was a
So
professor emeritus
what
for a
is
while.
that like? It's kind of a unique situation. Like, are there some years where you were clearly more productive than she was, and you know, are you at all competitive, or how does this work?
So I still don't have nearly the citations.
Inquiring minds want to know.
I have on camera. I have not nearly the number of citations that my mother has, but given that she's doing less research nowadays, I hope to catch up someday.
I see.
But no, Mom and I've all really so just for as background, my mother was a professor in oncology. Did a lot of work on cancer diagnostics, looking at multiple myeloma, cancers of the blood and bone. And for a long time, actually, my mom and I collaborated on automated diagnostic equipment, tricorders, lab-on-a-chip devices to very quickly test for things like cancer, or especially blood and bone cancers, or the ability of different cells to, say, uptake chemotherapy agents, things like that. More recently, we've worked quite actively together with collaborators from agriculture and life sciences on devices to test for E. coli, salmonella, and consumable foods like meats and lettuces and all sorts of other things. So we're just wrapping up some of that line of work. But yeah, we've really actively collaborated, and it isn't particularly competitive. We do very, very different things, but it sort of Lego blocks together really, really nicely. And a lot of what a good portion of what I know about how to do good science came from when I was a kid, even just drawing my little crayon diagrams on the back of 200-page CHR grant proposals that my mom had been printing out. So I owe a lot to Mom on how I do my science, and I don't think it's ever been really a competitive process. It's really been a learning process and a good collaboration.
So you would each have a Google Scholar page, right, with all those various metrics?
We do indeed. You can bring them up.
Yeah, and so as your career goes on, at some point you will exceed your mother's probably.
My curve looks like this right now, so I don't know where the intersection point is, but we'll find out. That's we could start taking wagers on when the intersection point occurs.
Right. Yeah. Okay. No, I just think that's a nice human interest side to things. So.
Cool. Any other questions, folks, or is this? Are you good? Was that helpful? I guess my question for all of you, was that helpful in starting to understand how machines might make decisions? Yeah? Learning through trial and error. We often ignore this. I think it's really important. I'm biased because I'm a reinforcement learning researcher, but if you leave with a better understanding of how machines can make decisions based on their raw, subjective stream of experience, then I think we achieved our objectives for the day. So it sounds like that was yes.
So on Tuesday night, Rich Sutton talked to the community in the part of the city where he and I live. I hadn't really experienced that, So these were just ordinary people, and his wife is on the executive of the community foundation and so on. So it was completely different. I pride myself on the fact that students here can be from any walks of life, any faculty, and they'll still get something out of the course. But he was even more general. He talked about the singularity without ever using that word, and he asked how many people knew what Moore's law was and stuff. But it was kind of cool to see a true talk by somebody who is a real expert that was sort of at the level of the real general public, and so it was, and he wondered why I said I wouldn't miss this for anything,
I wish I did. I wish I would have been there too. This is
yeah.
We all should do more of that, and it's increasingly important that we do actually do more of that. I mean, the field of machine learning and machine intelligence and AI is something that can seem very abstract. It can seem scary. It can seem almost black box to the general public, and I think in the end that there's a lot of aspects of it that really are actually very clear and interpretable, and we all need to do a better job, I think, in the community and all of us that are in fields relating to things like artificial intelligence need to do a better job of making sure that every time we present material that we also make sure that it's interpretable in a way that the general public that can actually understand it and make informed decisions about it. I think that's really, really important. When I go give my talks to AI and medicine to my clinical colleagues, it's usually how is this actually going to start to roll out in your daily life, in your daily practice? And that's really important. We need to do more of that. So I'm glad Rich is doing that, and he does a good job. I'm biased, but he does a great job of it.
Now he jogs in the morning at 7 something, and it's a time when I'm usually not home, and the first time I encountered that, so he turns around, head back the other way in our driveway, because we're like the last house of the block. I was trying to think, what is the cosmic significance of this, that Rich Sutton is turning around in his jogging run in our front.
He saw Kim looking in the window, he's like, uh-oh, run away.
Someone else, it doesn't mean anything except you're the house at the end of the block. I said, okay.
You're a good landmark for turning around when going for a short jog in the winter.
Yeah.
All right, we are after time. Thank you so much, everyone. This has been really fun. I appreciate you being interactive. I really like that. It's great.
Okay.